All right, let's go ahead and do number, let's see, I'm not quite sure what number it is, but it is the one that's talking about the oxygen supply. Because of an insufficient oxygen supply, the trout population in a lake is dying. Population's rate of change can be modeled by this, where t is the time in days, t equals 0, the population is 3150, and I need to find a model for the population. All right, so here's what I'm doing. This right here is a rate of change, because you have dp over dt. Whenever you see a fraction like that, that's a rate of change. And I need to go back to the population model. Okay, so you can think of this as being the derivative, and I need to go back to the function that this is the derivative of. That's integration. I'm going to go from a rate of change, and I'm going to go back to the original function, which is going to be the population function. All right? So if you're taking a test or anything and you see a rate of change and it's asking you to find a model for just this top part, this p, in this case it's a p, that's going to be integration. You need to integrate this function right here. And that's what I'm going to do. I'm going to integrate that function. Well, I can see that this is a function. You see that right there? Negative t divided by 30. That's a function inside of another function. So I'm going to take that inside function and I'm going to call it u. So I'm going to say that u equals negative t divided by 30. And as you've seen in previous problems, when I'm doing u substitution, I have to take the derivative, du, of this thing right here. The derivative of this, I can actually rewrite this as negative 1 over 30 times t. These are the same thing. Negative t divided by 30 is the same thing as negative 1 over 30 times t. Because think about if I multiply these. Negative 1 times t is negative t. And on the bottom I have a 30. These are the same. So if I take the derivative of this thing right here, it's just going to be negative 1 over 30. So du is going to be negative 1 over 30, and that's going to be du, and it's going to be dt at the end. All right? That's u substitution that you've seen in previous problems. Now, what I'm going to do is I'm going to see if I can rewrite that whole thing, this whole function right over here, in terms of u and du. So I'm taking the integral of negative 105 e to the negative t over 30. Well, and it's going to be with respect to t, dt. So it's going to be the integral of negative 105 e. You see this negative t divided by 30? Well, that's what we said the u is equal to. So I'm going to replace this with a u. Right there. I'm going to replace that with a u. And this dt, I need to replace it with something that has a du in it. Well, dt, I can actually solve for a dt. To get rid of this, to get rid of a negative 1 over 30, I'm going to multiply both sides by a negative 30. Negative times a negative is a positive. That 30 cancels out that 30. And I'm going to multiply this by negative 30. Okay? So right here, dt equals negative 30 du. And the reason I did that is because this dt, I need to replace it with a du. Well, dt is negative 30 du. So that's going to be negative 30 du. That's a u, du. And if you remember, when you're doing integration, you can pull out the numbers. So I can actually pull that negative 105 outside the integrand, and I can pull the negative 30 outside. And when I do that, I'm going to get negative 105 times negative 30. Okay. Then I'm going to still have that e to the u du. All right, so I just pulled this outside, I pulled this outside, and what was left over is this and this. Well, I know how to take the integral of e to the u. The integral of e to the u is just e to the u. It's a unique function. Its integral, it's equal to itself. All right, so when I do that, I'm going to multiply these two things together first. Hold on one second. Let me get to my calculator. Negative 105 times negative 30 is 3150. So that's going to be 3150. And the integral of e to the u is just e to the u. And I'm almost done. I just need to plug back in my u, which was negative t over 30. So the final integral is 3150 e to the negative t divided by 30 plus c. Don't forget that plus c. These are indefinite integrals, so you always have to have that plus c at the end. That plus c can be any number. But that's not what I want. That's not the answer yet. I don't want a c. I need to find not the indefinite integral. I need to find a specific function. Well, they give me some extra information. They say when that t is equal to 0, the population is equal to 3,150. So what I'm going to do, I'm going to put a 0 into my t. So right here, I'm going to put a 0 into this t. And my population, I'm going to say, is 3150. So remember, this right here equals the population. So into my population, I'm putting the 3150. 3150 equals, I'm going to drop that 3150 down. E into my t, I'm putting a 0. So that's going to be negative 0 divided by 30 plus c. And the reason I'm doing that is because when I plug in these two numbers, remember I just plugged the 3150 into the population. I plugged the 0 into the t. I can now solve for the c. And that's what I'm going to do. Negative 0 divided by 30 is just 0. So this whole thing right here is 0. E to the 0 is 1. Anything to the 0 power is 1. So e to the 0 is 1. So this whole thing right here, that whole thing goes down to a 1. And 1 times 3,150 is 3,150. So that whole thing right there goes down to 3,150 plus c equals, and drop down that 3,150. And I'm solving for the c, so I'm going to subtract 3,150 from both sides. And when I do that, I get c equals 0. See that? 3,150 minus 3,150 is 0. So c equals 0. Now I can write my specific function. So the reason I did all that, remember when you found the indefinite integral, you had this. But I need a specific function. So I have to solve for the c using the information they gave me. So that's why I plug that stuff in. And when I plug it in, I can now solve for the c, which I did. The c is equal to 0. So up here, I can actually replace that c with a 0. And that's your answer. That goes right here. It's going to be 3,150 e to the negative t divided by 30. Okay, that's your model for the population. Now I'm going to erase all this so I have enough room to do B and C. Okay. B, right down here, it says, what's the population after 12 days? Well, I can use the population model that I just developed. All I do is I put a 12 into the t. So I'm going to go 3,150 E. I'm going to put a 12 into the t, so it's negative 12 divided by 30. And I'm going to go ahead and put that in my calculator and see what I get. And it should be my answer. 3,150 E. And the E on your calculator, there should be a button that has E. E is not a variable. E is a number. E is equal to like 2.7. It goes on forever. E is actually a number. 3,150 E to the negative 12 divided by 30. Let me make sure I put that in right. 3,150 E to the negative 12 divided by 30. When I put that in, you might want to put it in your calculator, make sure you get the same answer. It's going to be 2111.5081. And it says round your answer to the nearest integer. Nearest integer is going to be over here. That 5 is going to bump it up to a 2. So your final answer is going to be 2112. So that right there, that answer is going to be 2112. That's how many fish you will have after 12 days. Then I'm going to go to C. C says, how long will it take for the entire trout population to die? Assume the entire population has died off when the population is less than 1. Oh, hold on a second. Round your answer to 1 decimal place. Okay, well, that kind of makes sense how they worded it. All right, let me erase this. So I'm going to set up that. I was going to set up an inequality and put 0 into the population, because when it dies off, there should be 0 fish. But that's not how they want you to set it up. They want you to set it up so that you assume it has died off when the population is less than 1. So I'm going to go ahead and go back to this model right here. That's the population. I'm going to say the population negative t to the 30th. I want to know, when is that population less than 1? Because when it's less than 1, I can assume it has died off. So I need to solve that. And whenever you're solving these inequalities, it's the same process you go about doing when you're solving an equation. There's only one difference. If you ever multiply or divide by a negative number, this thing switches. So if we ever divide or multiply by negative, I have to switch that inequality. Otherwise, it's just like solving an equation. So the first thing I'm going to do, I'm going to divide both sides by 3,150. That's gone. So I have E. And by the way, I'm solving for the t. I want to know what that t is when it's less than 1. So it's going to be negative t divided by 30 is less than 1 divided by 3150. Okay. And now I need to solve this exponential. This goes back to pre-calculus and algebra 2. Whenever you're solving an exponential, and I know it's an exponential because my variable is in my exponent. Whenever I'm solving exponential, I have to use logarithms, and that's what I'm going to do. I'm actually going to use a natural log. A natural log cancels out the e. A natural log is the inverse of e to a power. So if I multiply, I don't want to say multiply because that's not multiplication. If I take the natural log of this function, it will cancel out the e. And what I do to one side, I have to do to the other side. So I got to take the natural log of that. So on my left side, I'm left with negative t divided by 30 is less than the natural log of 1 divided by 3,150. We're almost there. I need to get that t all by itself. First thing I'm going to do is I'm going to get rid of that 30 by multiplying both sides by 30, which cancels these 30s out. So I have negative t is less than the natural log of 1 divided by 3,150 times 30. And now I need to get rid of that negative. To get rid of that negative, I can just multiply by a negative 1, because a negative times a negative is a positive. But what I do to one side, I got to do the other side. So I also have to multiply this by a negative, which is just going to make this whole side here negative. But here's what I was talking about. When you're solving inequalities, if you multiply both sides by a negative, you have to flip the inequality. So that's what I'm going to do. Negative times a negative, that gives me a t over here. I'm going to flip my inequality, and then I'm going to have negative natural log of 150 times 30. And this right here, that I am going to plug it into my calculator, and I'm going to see what I get. So hold on one second. Negative. This ln, you should see that on your calculator. Should be a natural log button. 1 divided by... You just got to be careful when you plug it in there, because you need to put parentheses around the 1 divided by 3,150. Hold on, plugging it in, making sure I do it nice, neat. Yep. So I have negative natural log 1,300 times 30. And what I get when I plug that in is 241.6547. And it says round to 1 decimal place. So I need to round to 1 decimal place. This 5 kicks that 6 up to a 7. So it's going to be 241.7. And that should be the answer right there. Let me do one check to just make sure everything checks out. I like to check my work, make sure everything's good to go. So give me 1 second. E to the 241.7 divided by 30. Was that days? Hold on 1 second. Oh, that's a negative. Yep, that's right. So that's your answer right here. 241.7. So I'm going to end this video. It's getting a little bit long. And then I'll come back with another video for, I think it might actually be the final problem.